Hello everyone and welcome to another episode of FiST Chat, the vodcast that features discussions on the topics of film, science and technology. My name is Ben Warner and I'm joined once again by my good friend Steve Kern. How you doing there, Steve?
Hi everyone, I'm well. I'm enjoying episode number 20 of FiST Chat.
We finally got there, didn't we? Just we stuck through thick and thin, and who knows where we can go to from here.
Episode 21.
Oh, of course. So, don't forget our website, www.fistchat.com. You'll find all our social media and other links there, Facebook, Twitter, YouTube, iTunes, you name it, it's there. You can interact with us there, leave a comment or ask us a question. Depending on what we get, we'll incorporate it into the show. It's all building quite well. Just to reflect on now that we've got to episode 20, we've got 7,000 odd fans on Facebook, which never would have expected that after only a couple of months on the net, or I was going to say on the air, but we're not really on the air, are we? We're a bunch of ones and zeros on people's computer screens.
Well, that's right. That's probably a good point to start on this one with the science fiction to science fact. Who would have thought that anyone could have had their own, vodcast, 40 years ago?
Well, it's just so easy, isn't it? But the thing is, even though the technology makes it easy, you still got to make it interesting. So, of course, we're hoping that people are finding us interesting, which I'm sure you guys are. But
and I love it when you ask us questions out there. So tweet us with any questions you have. We'd love to hear from you.
Absolutely. So as we're alluding to there, the topic we're going to focus on today is future technologies. As we were just having a quick chat before we got started about how, today's science fiction, which might present all these fanciful type of ideas or products or technologies, will probably take for granted tomorrow. And things that maybe we didn't even imagine would, come up, or things that we did imagine may never eventuate. That's the amazing thing with technology and its progression. But we've got a couple of ones that we like to focus on, and they have different applications, of course. Just the first one that you showed me there, Steve, nuclear power, which was quite interesting. That always generates a bit of controversy about whether, people are into it or not, or whether they support it or not. But fourth generation nuclear power, which from what I was reading was still in the theory stage, is sort of like they haven't actually started building any of it yet.
Oh, look, there are some great links which I might put up on the site a little bit later on for people to read more about it. Fourth generation nuclear power is the next step in terms of nuclear power. If you think about how we use nuclear power today, effectively the efficiency is I think sits somewhere at about 1%. So I think the analogy is that if you were to throw a log on the fire using today's nuclear technology, you'd sort of just burn the bark off the outside of the log and throw the rest of the log away. The advanced nuclear technologies use all of the fuel. And in fact would be able to reprocess all the waste that's available today actually as a fuel source. So it's unlimited amounts of power, literally. And what's interesting about that is that if we were to go to the next level with power and have unlimited power supplies, that's where science fiction starts to become science fact. You could have incredibly powerful motors. You could have incredible power available in every home. I mean, some of the heating you would have could be instantaneous, electric. You could have plasma incinerators for all your waste that might just reduce whatever you throw in there back to its constituent elements, which you could harvest and then resell. In terms of, the world globally, it would mean then that energy wasn't just restricted perhaps to the wealthy nations, but it would then actually become affordable, probably for all, even in developing nations. It's an interesting concept, but that's why it's science fiction.
Well, that's almost like an energy utopia, isn't it? This idea that it's almost like a circular thing, you never really actually waste anything, really. It's sort of it's the ultimate recycling machine.
Well, that's the challenge. If you can get over that energy hurdle where you have, unlimited energy for the population, then in those sci-fi films and the books that you see, where you see the little silhouette and all the jet cars or electric fly cars flying around and zooming around, they suddenly become possible.
Absolutely.
So that's you need power to drive that. So you need a lot of energy to do that. And unfortunately, no matter how much anyone loves fossil fuel is never going to give us that.
And I think that's one of the other aspects too, is that wind, solar, and sort of those renewable energy sort of sources. There's still a question mark as to whether it could actually, on its own, provide all of the electricity needs for us. And I guess that's where an option like this might come into it.
Well, yeah, I mean, look, in the short term, those renewables that you mentioned, like wind and solar and wave, they all have their role, and they have their role in self-sufficiency. And in a dystopian future, after our utopian limitless power world falls apart, we'll have to go back to those solar panels, and then that might be the other science fiction to science fact. If we can't get the energy situation right and society goes backwards and we're living in the trees, maybe a windmill might be the future.
Well, it's all very cool. All right, if we move on to the next one, nanotechnology. Now, this is another very interesting one, and has popped up in science fiction quite a lot. The idea that you can work at the molecular and atomic level to, I guess, produce and repair things. Can you maybe just take us through that?
Well, I think nanotechnology is about very, very small things, and because now we actually have the power for the first time to see very small things and actually control them, we can build micro machines. And when I say micro, I really should say nano machines, machines that are 1 billionth of a meter in size. I mean, that's tiny, and that means then that you can have actual machines, that can do work, that can move, that can actually achieve things. If you team that with things and advances in things like synthetic biology now, where they can start to create these, micro machines within cells that are biological, so you're almost talking miniature cyborgs there with these sorts of technologies. There's a whole host of applications, from going to places that we can't normally go, and that, I mean, on the small scale, getting perhaps deep into the earth and having a look down deep into the earth, or sending things out into space very easily because these machines are light and reactive, or even medicine, where you could ingest some of these and they could go in and perform cellular repairs. What was that film which had the miniaturized in the person?
Oh, that was Inner Space, wasn't it?
Space, but I think there was a 1950s B grade like that as well.
Yeah.
So, I mean, potentially you could be doing that sort of thing.
Could there be potential that even though there's like so many good practical uses for like such a technology, I was reading up that there could also be some dangers involved as well if it was used for nefarious purposes?
Look, yes, of course. Anyone can do anything that's bad. You can do a good thing with a gun, you can do a bad thing with a gun, and that happens the same with technology. And I think that's why it's so important that people take an interest in science and these new areas of science, because one day, if it's not you, it might be your children, will have to make decisions. And the only way to make a good decision is to understand, the technology, and not to be fearful of it. I mean, these technologies, even if people may have the opportunity to use them for bad, they usually are discovered or generated from people wanting to do very good things, and I think that's important to remember that.
Yeah, absolutely. All right, here's another good one. We talk about computers. We've talked about computers a bit on FiST chat, and photonic computers sound really interesting. The idea that rather than electricity, they're based on light, which obviously travels a lot faster. That obviously make the computers a lot faster than what they are now, right?
Absolutely, and it also allows you to design them differently. Okay, so at the moment you actually have to create electrical circuits on a board, but with light, all you need to be able to do is, get it from one point to another. And we know that using optic fibre, you can even tie an optic fibre in knots and still get the signal through. So basically, it's all about light. It's a lot quick, and it gets back to the whole idea of unlimited power again. If you have a computer with unlimited processing power, then all of a sudden things become possible that today are possible. Such as even if you compare our brain to computers, we tend to think of the brain as highly complicated, which it is, and the thought processes are highly complicated. There are billions of them happening at once and being processed at once. However, if you can apply or have faster computing, then technically, I guess you could be able to do what the brain does. And that would then truly open the doors of science fiction once again, where you could have, computers or robots conversing with humans, on an intellectual basis. Perhaps we'll finally see someone pass the Turing test, or I should say something pass the Turing test, which of course is the intelligence test for robots.
No, then we're getting to the stage where it could be, becoming more than the sum of its parts, which is basically what we are, I guess.
Yeah, and I'll just very quickly, I'll say one other thing that you could use, not just photonic computers, but photonic devices for, because they work at the speed of light, you can actually capture images at the speed of light, which I don't know how many frames a second that is for the tech heads, but that's a lot of frames a second. But it would mean that you can actually witness chemical reactions taking place. And that's truly amazing.
Absolutely.
You see the interaction between chemicals and the changes occurring. At the moment, some of these happen in such little time that it's just incredible.
And and the last one that we've got here is stem cell technology, which of course that's been discussed quite a bit in the quite a few years now. There's always been some those working for, those working against, whether it's things that we should be doing or whether we shouldn't be doing it. But the underlying science and the technology behind it has a lot of potential there to do a lot of good.
Well, absolutely. Look, people can be worried about, people creating monsters, and I think there are enough humans who qualify as monsters not to be worried about breeding in a lab. The papers are full of them. I don't think I need to say anything more about that. Likewise, when anyone sees a child who's badly injured or has a disease, no one wants to see a child suffer. And with these sort of technologies, we can help them have a normal life and a happy life. And I think that's very important. But, look, if we just want to be vain about it, if you want to stay young and good looking forever, these are probably the technologies that are going to allow you to do it. I can't hear anyone in Hollywood complaining about that.
Oh, no, of course not. They'd just be replacing body parts left, right and centre, wouldn't they? They're doing it already, but now they can, grow up from their own DNA.
Don't worry, FaceTime will become a reality before anything else, I'm sure.
Absolutely. But, I mean, that's just an amazing thing. That really does sound like a very sci-fi idea, the idea that you could replace organs or replace body parts or whatever. And I remember I saw something the other day. I only caught a glimpse of it, but essentially it was a report basically saying that, you could take these types of stem cells and, adjust them to, suit whatever purpose that you need it for. But if you ever really think about, what it would take to be able to do something like that, who would have thought, how did they come to this conclusion about how did they figure this out kind of thing? And it applies to pretty much all of the stuff we've been talking about. It's just an amazing thing that, with enough study, with enough research, with enough discovery, it's amazing what you can find out there.
Well, and that's why everyone should be encouraged to take an interest. You don't need to be a research scientist to have an interest in science, and you don't need to be, necessarily, working in a field to have a vision. I mean, I'll perhaps leave you with one thing to think about on the things we've spoken about tonight. You imagine if through stem cell, research, you can live longer, happier, lives. I'm not going to say immortality, but longer, happier lives. What if you can combine, some of that photonic computing to make you kind of a cyborg, kind of human, but with incredible, intelligence and ability? And, what if you could make things out of synthetic biology or small nano machines that you could put on so including yourself to give you superpowers. And then what if on top of that we had unlimited energy and we're driving around in plasma rockets, from planet to planet? That's science fiction, and I reckon that'd be fantastic.
Living in the world of the Jetsons right there. Oh, on that note, that's a great place to finish up. So thanks again, Steve, for the chat. That was quite interesting, as always.
Always, yeah. Any questions, tweet us.
Absolutely. We're ready and willing, standing by, waiting for your call. Absolutely. So yeah, that wraps up another week here at FiST Chat. We'll be back again next week. So have a good week while we're away. Check us out on the net, www.fistchat.com, and we'll catch you next week.